Okay, algebra, let's finish 1.6, the last few sets of radicals, and one other thing, things that behave like quadratics, and we'll get there in a second. If you've got two different radicals, you're going to end up having to go through this process twice where you isolate the radical and square, because there's no way to get radical by itself unless this isn't a 1. So I'm going to move the minus square root of x minus 13 to the other side, so it's 1 plus square root of x minus 13. Now we have one radical isolated, so I can square. However, on the right side, this means I'm squaring a binomial, so that's a 1 plus square root of x minus 13 times another 1 plus square root of x minus 13. This is x squared. Sorry, just x. This is 1 plus 2 square roots of x minus 13 plus an x minus 13. And you can write it out where they're right next to each other and FOIL or use the distributive property, but I'm just going to quickly go through that for now. Okay, so now I still only have one square root left, so I need to get that one by itself. Which means I need to subtract x and add 13. So I get 13 equals 1 plus 2 square roots of x minus 13. Subtract 1. 12 equals 2 square roots of x minus 13. Divide by 2 to get it by itself. We get 6 equals the square root of x minus 13. Now finally I'm down to one square root on its own side, and I can square again. So I get 36 equals x minus 13. Add the 13. To get x equals 49. Now, if I want to plug this back in, square root of 49 is 7. 49 minus 13 is 36. That square root is 6. Is 7 minus 6 1? Yes. Now, let's look at the easiest kind of problem. If there are two roots on both sides, regardless of what kind of root it is, and there's nothing else, there's no 1 in there complicating it, this allows me to raise to a power at the very beginning. When you raise to an odd power, you don't have to check your answers. It's only when you raise to an even power that you really have to worry about it. And that just takes me straight to 8x minus 9 equals 9x plus 3, an easy linear. Move my 8x to the right, negative 9 equals x plus 3, and subtract 3. So x is negative 12. These are the ones you like to see more than the others because they're the easiest. They require less work. Particularly the odd roots, you don't even have to check your answers. Now, the last kind are things that don't look quadratic but behave like quadratics. Now, what is your tell that this is going to be the case? You've got a constant at the end, and you look at the powers here. If the first power is double the second power for 2, or down here, 2/3, 1/3, then that tells you that it's going to behave like quadratics. It's just not. Now, how do we deal with this? Well, we can look at this as x squared squared, because x squared squared is x to the 4th, minus 17x squared plus 16. So the way you're always going to work this is I'm always going to say u equals whatever's squared here, that's u. U equals x squared, so this becomes, I'm going to substitute it in. U squared minus 17, and we know u equals x squared. Here's an x squared, so it becomes u. Equals 0. Now I can, look, this is a normal quadratic I can factor. This is u minus 16 and u minus 1. That means either u equals 16 or u equals 1. But the point of substituting is to make the factoring easier. I still need to go back to my x's because that's where the problem started. So instead of u, I need to go back to x squared equals 16 or x squared equals 1, which means x is plus or minus 4, x is plus or minus 1. Now, it's an x to the 4th, so we expect it to have 4 answers. Here are 4 answers. It doesn't hurt to plug it back in and check. In this case, particularly with something like number 10, we'll have to check. But because we didn't have to introduce any roots, it shouldn't be a problem. But 4 to the 4th is 256. So this is 256 minus 272 plus 16, so that is 0. When I plug in 1, I get 1 minus 17 plus 16, it's also 0. So all 4 of these are answers. Okay, let's look at number 10 as well. X minus 1 to the 2/3 plus 3 times x minus 1 to the 1/3 minus 18 equals 0. So again, if you see it, it's double. 2/3 is double 1/3. So it's really x minus 1 to the 1/3 squared. Because of the way the laws of exponents work, that's how it works. Whatever's inside here is our u. U equals x minus 1 to the 1/3. So this becomes u squared plus 3u minus 18 equals 0, which is a lot easier to work with. Two numbers that multiply to negative 18 that add to 3, u plus 6, u minus 3. So either u equals negative 6 or u equals 3. But again, I didn't start with u, so I need to substitute back in. So we get x minus 1 to the 1/3 equals negative 6, and x minus 1 to the 1/3 equals 3. Now, fun fact, if you see a fractional power like this is the same as a root. A 1/3 power is a cube root. A 1/2 power is a square root. Now, normally to get rid of a cube root, I would have to raise it to the 3rd power. So we raise both sides to the 3rd power. So we get x minus 1 equals negative 6 cubed is negative 216. Here I do the same thing, raise it to the 3rd power. We get x minus 1 equals 27, because 3 times 3 times 3 is 27. Add our 1 on both parts. We get x is either negative 215 or x is 28. Now, we don't have to check our answers in this case because this is an odd root, so we raise to the 3rd power, which means we don't have negatives becoming positive in this case. However, if this is an even power where you have to raise to an even power there, you really need to plug in and make sure that these work. And that is all for 1.6.